Okay, for people joining this live stream, this is hopefully the last of our current series of meetings about image and signal processing functionality for the next version of Wolfram Language. So, what is this first thing here? Sorting function. Why is Jose suggesting renaming this?
So the function in sort or sort by is called the ordering function. And this is the option we're introducing for now for face recognize, or sorry,
but
find
it
face.
works like sort by, is that correct?
It works like sort by, yes.
Well, what would you call the function? I mean, in other words, if it was going to be called something, I mean, another possibility would be sort ordering function. Or is that wrong? Because we already have a thing called ordering, which does something completely different.
I think ordering is the thing that returns -1, 0, and 1. So that would be really wrong. It
Yeah,
really
okay.
is.
Well, what is it? In sort by, what is the...
I don't know if it has a name. Let's look at that. See what I'm saying? We're not giving it a name because we
By
don't
the way,
have...
something is wrong here. There's a space that's come out after the that started to happen in places like that. There's some bug there. This is a recent issue. I'll send it to you docs. Okay, sorry. Okay, so, well, what would it be? I mean, it's kind of like a ranking function of some kind. Am I making sense? I don't think it's obviously wrong to call it a sorting function.
I don't think so either.
Fine. And I mean, if sorting function ends up being also an option to sort, that's the by type function. Yeah, it says an ordering function there. So we haven't called it a sorting function. So I think that's fine. Okay, I think we should, in ILD, we should discuss whether sorting function wants to become an option to some things like sort itself. Make sense?
Sure.
Okay, is somebody able to take that as a note?
Yeah, I'm taking some notes. I'll send it along.
Okay, great.
One thing that Jose was suggesting is that, like in the case of find faces, one reason why we need sorting function is that the result may not include all the properties that we may want to sort by, like the age may not come back as the result. Mm-hmm. And Jose was suggesting functions that do return all the properties needed for sorting should not be extended to have the sorting function, but for anything else, it makes sense to have this option added.
Wait a minute. Even if it returns all that stuff, it doesn't mean that we know, do we want youngest first, oldest first, whatever, right?
Right.
I think this is fine.
No, but at the same time, you could say it's just a sort by function around the result. And that was his argument.
Oh, I see. Well, that's not an unreasonable argument.
Right.
I don't think this hurts anything. Okay. Color neighborhood. So, color neighborhood represents essentially an interval in color space, right? Except it isn't an interval.
Yes, it's a neighborhood, really, or a region.
Is it a disk?
In LAB, yes. Not in all other spaces.
Okay. Color neighborhood is such a weird name. What else do we have that's a neighborhood function? Nothing. What are some synonyms for that? What else? What would this be mathematically called? Any ideas for that?
A region, really?
I don't know, but it's a specific region. It's a region that has, it's a disk actually in some space, correct?
Right.
What about
Sorry.
Some ellipses, right?
what about color space disk? Well, how do we spell color space? Do we use color space? Do we have something where we have a color space?
We typically spell it with capital S. If we have,
but is this
color
correct
space.
that it is in fact a color space disk?
No, it's an ellipsoid, isn't it?
Yes, it
No,
is.
it has a maximum distance. It's a single distance d. That's what I would call a disk.
Yeah, but the minute you change color space, so you can say, so what are things that are nearby colors? It's nearby in one space, but it's not so near. It's it might look like a disk in one space, but it's not in another space.
No, I understand that, but I'm saying
It's
that
still
this
the
is
same color. It's still the same region of colors.
yes, but you have to say what space it's a. Or is it always in one particular space? Can you specify a different color space here? You can, right?
You can specify different distance functions, yes.
I don't think we know exactly what shapes they are.
Okay, but why is this why is it called a distance function here? Because a distance function actually has to be something that you can apply to two values to get back the distance between them.
Right, that's the last entry of the list, f, a function that is given.
No, I know that, but CIE 76 isn't that, right? I mean, it will be color distance of, right? It's color distance of, red, blue. That will give something, but color distance of that, and then CIE 76. Right?
Distance function, CIE 76.
Why? Color distance it's not taking a distance function. Right? A distance function is something which, when applied to two values, you can't apply the string CIE 76, right?
Right, so that can be specified as a distance function setting.
No, but it shouldn't be. Why is that working? What is the full functional form of distance function arrow CIE 76?
We don't have it. But I see your point. You want some carried form of that or something,
yes,
right?
You can, as a shorthand, say distance function arrow CIE 76, but it has to have some actual full form like this. You see what I'm saying?
We should have that. That wouldn't hurt for us to have. That would be a good thing to have.
Right. I mean,
but I'm just saying that these are, these are kind of nonlinear transforms from RGB space if you're used to that.
I understand that, but why? But when you say color space disk, okay, of red, for example, let's try color neighborhood. I have to go to prototype build, right?
Yes.
If I say color neighborhood of red, for example, this will only start up. Oh, come on. Hello. Great. Application not responding. Okay. We have somebody here who could report that. Or do I have to?
I'll report it.
Yeah, dead in the water here. Okay, let's try. Oh, wait a minute. After I told it to quit, it came up. Let's try the Mathematica build. See if we have the same problem. No, that one looked better. Okay. Okay, so I say color neighborhood. Oh, come on, what's it doing? By the way, that pull down, again, something that should be reported, the middle of that pull down should come up as, that new pull down should have the 100% in the middle. I'll report this. Okay. All right. So here, color neighborhood of red. Does it have a default? What is that doing? Does it have a default region size, or what is it doing here?
It does have a default region size and distance function, but it doesn't evaluate to anything. It's just a wrapper. It's just a symbolic representation of that neighborhood.
Why doesn't that work?
It should eventually. That's something we've thought about.
Okay. But so how do I get the picture? Oh boy, somebody on our live stream is pointing out that distance function already has the inconsistency because image distance also doesn't correctly deal with, yeah, this is wrong. I mean, this is just wrong. This should never have been set up this way. That apparently image distance also does it like that, which is wrong.
Mm-hmm.
Okay, so let's look at all of them.
You think that one as well should just take the distance measure as a third argument?
I do. Yes, I do. And if you want to give it a distance function, it can, you know, you can use the whole thing, or you can do whatever you want, 1 over image distance or whatever, if you really want that to be the distance function.
Right. So color distance is just supporting 2-argument form. Image distance already uses 3rd and 4th argument form as some alignment positions.
This was a mistake. See, that is fine. Oh, if it's a Euclidean distance, as in, yeah, Euclidean distance is fine because it's a function, but this, maybe, wait a minute, we're confused here. This is the right form, right? Because that, wait a minute, there should be a function, right? It should always have a function as the right-hand side. Right here. What's happening here? The following distance function.
So we have some string settings.
Oh, gosh.
That define, basically predefined functions that are not already system-defined functions.
Well, why aren't they system-defined distance functions? We got a whole zoo of system-defined distance functions. Why aren't these useful functions?
I guess not all of them have use in other places. Some of them may have. I guess mean Euclidean distance is an example of one that can be.
Which ones cannot be?
Yeah, well, we can go through this and see how many of them.
Let's go through it. Okay. I mean, look, we can get away with some strings like this, but they really should have a full functional form. Growl. I didn't notice that before. Oh, dear, dear, dear. Okay. All right. But let's not compound the mistake here. I'm going to come back to saying I like color space disk. I think it's very clear what that means. So long as you say what the color space is, and there's, you know, there can perfectly well be a default color space in which the thing is a disk.
Okay, so
I mean,
color spaces are 3D, right? So you think a disk is a 3D thing? Just saying.
No. I mean, you're right. But this thing is, in fact, a 3D thing, correct?
Yeah.
Okay. All right. I'm wrong about that disk thing. So, I mean, it would have to be color space ball, which is then getting very, very bizarre. And one's thinking of, you know, colored balls and weird nonsense like that. So that doesn't, I agree, color space ball is crazy. I don't like color neighborhood. I don't know. I can't tell you. Okay, let's keep going. I mean, what is it, in fact? It's a ball, correct, in a certain space.
Mm-hmm.
True?
Yes.
Yes.
Okay, so let's try to understand what some other things that are like that might be. Okay? Do you have suggestions?
So region seems reasonable if then this gets extended to support arbitrary shapes rather than just a distance function. but I'm probably
I
not.
think that the only downside to that is that it has no properties that region has.
Okay.
Do you know what I'm saying?
Yeah.
It's the right name, but it's not the right name in the context of Wolfram language.
I see.
Okay, so I mean, there's words like locale and vicinity. I don't think that makes sense. Locale tends to suggest some internationalization thing. It seems too colorful.
There was another suggestion. Name was color mask.
No, that reminds me of some bandit or something. I mean, I don't know. Okay, let's look again at how this is used. Okay. So
it is in effect a way to select a piece of an image by color.
Wait a minute. What on earth is this form here? What on earth is this?
Which form?
This one here. What is this?
Oh, sorry, I had one window in front of yours.
What is that? I mean, that's a completely different thing.
Right. So this is what Roger...
That makes no sense. This makes sense, right? That the
But then color mask may make sense.
Yeah, but then it's a different function.
Okay.
This, whatever is doing this, has nothing to do with this.
Right. We've discussed separating that syntax from color neighborhood.
Well, good, because it's the right thing to do. I mean, this is something completely different. What is this even doing? This is just saying, give me a color mask. Give me a mask based on that color, right?
Right. But
Okay,
it's
that has
taking
nothing
into
to do
account
with it.
the default distance and the distance function and so forth. So
Yeah,
it's
okay.
not just that blue.
I understand. I got it.
Right,
I got it.
right.
So I mean, in some sense, you could say, you could have a thing that says, I mean, this would really be, it's like edge detect, it's color detect, isn't it?
Yeah, it can be non-binary. It can be a grayscale mask.
Okay, how?
We have some smoothing parameters in color neighborhood.
Okay, fine. But so fundamentally, it's color detect.
Right.
And in principle, you could have a single color there, right? But you could also say color detect of, color neighborhood or whatever it's called of that.
Yeah.
Yep.
And I mean, that first thing would be useful, I think, because there are cases that I've even used where you just use a color, a very specific color, as kind of a hack for how to represent, let's say, missing data in a picture or something.
Right.
So isn't the right form color detect?
I like it.
Okay, so then we got to solve the problem of what is the name for the thing that represents is it colors around? The problem is we're using around in our very specific sense is this not a version which has an around in it? Oh, that's my version with an around in it, I hope. Yeah, so I mean, this is, that's that around. Okay, which is not a hard-edged thing. That is that's a mushy-edged, uncertainty.
What is around replace? Is that also something? I have it in my prototype build.
Yeah, around replace is a thing that has to do with the complexities of dealing with whether errors are correlated or not. It's kind of clever, actually. But I mean, this thing, if we take that thing, it's going to do the right thing, right? But that's a completely different kind of activity than the color one, right? Because the color one is hard-edged, correct? You're either in the neighborhood or you're not. It's not like this thing where there's, in a sense, this is like...
it can be soft-edged, and for the application...
When masking, right? But I think Stephen is... When masking...
Both crisp and soft edges are interesting, actually.
Right.
Okay, but so soft-edged and masking gives you grayscale, presumably.
Yes.
Okay. So, but a replacement has to know, are you in or are you out? It can't be, well, we're sort of partly in. Right?
Right.
So please don't have these things. I'd have giant essays on the right-hand side like this. Just have something simpler and then explain them afterwards.
Sure.
Okay. Why don't I like neighborhood? Somehow, it just reads very strangely, you know, color neighborhood of red. I mean, colors around red would read nicely. Comments. What is the default distance?
That's a Euclidean in LAB.
No. I mean, how far out? If I just say color neighborhood of red, how far out does it go? Do I get to orange or not?
Well, you get a little orangish, but no, not to orange itself. I think it's a 0.2 or something like that. It's still a fairly small.
Okay, so how does it relate to human perceptual, you know, color distinction?
If we want to be perceptually correct, we need an automatic distance, depending on where in the space we are.
Okay, that sounds highly useful.
Right.
Highly useful. So, I mean, that is that is a color distance setting of which of the color distances is the perceptual distance? Is that the CIE 76 one?
Yeah.
Okay. So, I mean, to me, that should be the default here, is a certain distance that is for, I don't know, I don't know whether the hypersensitive XX chromosome, you know, whatever they are, more cone cell folk, ignoring them, you know, the typical, there must be some standard color distance that typical people can distinguish. That should be our default for this function.
Makes sense. Okay.
Okay. So, okay, let's try another possible name, approximate color. No.
How about a generic wrapper? Approximately red, almost red?
How could that possibly work? I mean, are you saying you're saying almost 4, 0.2 means, within 0.2 of 4.
Mm-hmm.
So you would say something like this. I mean, that is sort of interesting to be able to do something like that. I mean, that would be more like, unfortunately, almost is a bad word for that. I mean, that's more like an interval thing.
Mm-hmm.
And we certainly don't support that right now, although it's an interesting idea to have some kind of interval replace.
What about something like within?
Yeah, I mean, I think these are all reasonable ideas. Let me, since we don't have anybody, we have nobody from project management here, is that correct? Seems like it. We really shouldn't do these without that. Okay. Okay, but I don't think that's going to work for the. I mean, that's a bigger, fish to fry, to have some general notion for arbitrary spaces of, the hard-edged, ball within that distance. So here, by the way, a comment on the live stream from Flip Phillips about n-dimensional color spaces, like hexachromatic spaces, apparently. Does our color system? It does in principle support that, because our images support any any number of what am I saying? Any number of channels, right? Do we support these other color spaces?
We don't support them, but yes, our images support n-dimensional, arbitrary n-dimensional channels.
And is there anything about our, clearly, you know, even with CMYK, as somebody was pointing out on the live stream, that's a 4-dimensional color space.
Right.
And we do support that, don't we?
We have CMYK. Where do you...
No, I understand, but I'm asking in color distance, for example, are we supporting the 4-dimensional CMYK color distance? Like if I say color distance between two CMYK colors, what does it do?
No,
It's converting to whatever color space the distance is defined in. So if you're talking,
you don't get more colors just because you have a different parametrization.
Right.
And CMYK, as you well know, solved a particular rendering problem for printers. You know,
Yes.
but you don't get more actual colors. That was just sort of like a device setting that was useful for printers.
No, I'm aware, but if you print in, you know, if you, you know, there's 6-color printing and all that kind of thing.
Yeah.
Where you've got more
Right.
basic colors and you're making things out of more colors.
Sure.
And you can get further into the blues and all that kind of stuff.
Right. But usually you know, there's no, okay. PDF and other, which are sort of printer driver languages of modern type, they have pretty sophisticated colors over. They have certainly the CIE spaces and all that. So you're not restricted to RGB or anything. That is a little bit limited. That means that if you have a printer that is 6-color printing, that is part of the responsibility of the printer.
No,
to
I understand.
Convert that to those 6 colors for optimal.
Right, but for our purposes, when we are measuring color distances, does it not matter? You know, in other words, the color distance in a 6-dimensional color space is obviously going to be different than the color distance in a 3-dimensional color space.
No, look, they can still be valuable, like that hexachromatic, okay? Maybe it's particularly convenient to parameterize some things in that space for some purpose.
Yep.
But on the device side, I don't think it's not particularly interesting. You know,
I understand. Getting the device output, its responsibility is to go from an RGB, like there could be an RGB color specification that is outside the region supported by a display that has, you know, it's just presumably it's just a triangle or something that is the region of the chromaticity diagram that the display with 3 things supports, with 3 primary supports.
And we'll be adding more color spaces for sure. We need more for video. We have other ones we need for visualization.
All right. Okay. Let's loop back.
It's not a low-cost thing to do, but we want to do it.
Yeah, I understand. But let's loop back to this issue. This issue is, what do we call the potentially hard-edged, the potentially soft-edged, you know, colors nearby? You know, what do we have? What's another place where we have a similar kind of thing? Do we have anything in Geo that's like this? Well, we have a notion. I mean, in Geo, we obviously have geodisk. And notice that geodisk, well, I don't actually know how geodisk is the actual distance on the surface of the Earth, I assume.
Yeah, so under different projections, it doesn't actually look like a disk.
Right, exactly. Right. But this is a different thing, because this is a different metric, an actual different metric in the space.
Right. So it could include different colors based on different metrics.
No, I get it. But so what's the right thing? And
it so happens, like for this, the recolor function, image recoloring, it's very useful to pick the perceptual space, because that's what you can see, first of all. And it's very useful to make it soft, because then you really can do the sort of make your shoe from red to blue type thing in images.
Okay, all right, fine. So hold on. So we've got I'm still trying to verbalize why I don't like color neighborhood.
Well, it's not perfect, Stephen. I agree with that. I didn't feel it was perfect, but we kind of struck out on.
Wait a minute. So let's. What is a neighborhood? A neighborhood.
Neighborhood is a simple. It's a simple region. So a neighborhood is topologically equivalent to a ball. You know, it can't.
Yeah.
It can't have tears and holes and other things in it. You know, and it's full dimensional, and so on.
Yeah.
So it's not necessarily a ball, you know, as a sphere or a ball, as you think of those simple shapes, but it can topologically it's equivalent to that. But the triangle
I guess one
like
of the point.
Disk.
Yeah, go ahead. What?
No, whatever shape you have, you know, a triangle is a disk in that sense.
Yeah, look, a disk is not going to cut it. Okay, we've got higher dimensional space. It's just stupid. Forget that idea. So I wonder if there's something more informal that, I mean, okay, so color approximation. I don't like that. It suggests the wrong part of speech. I mean, what do we think about something like approximate color?
We have another suggestion from live stream, color proximity.
The problem with that is that it suggests it is not a noun. I mean, the proximity, you don't say the proximity of my, you know, house is whatever. The proximity around my house, it would be, it's asking, it's more like a question. Color subspace. I don't think that makes sense because there are just too many. That could be such a big, you know, a color subspace could be just like forget the red type thing. I mean, that seems like a bigger kind of thing. What do we think about approximate color? Because that would.
I'm thinking when you say approximate, it just sounds to me like
it's
a particular one.
No. First of all, the way I said it already cheated because I could say approximate color, right, as opposed to approximate adjective color.
Right.
Okay, what do we have? What do we have for numbers? That is, I mean, we don't really have anything of this type. What do we have? I mean, like, where else do we have things that represent something approximately? We have it in power series. We have it in numbers. I mean, we have a notion of, for numbers, we are usually thinking of them as quite precise. So we might have a precision, but we don't have, you know, sort of a big thing like that.
No.
You know, if you saw a piece of code that says, you know, something like color replace, blah, 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 color neighborhood, it just seems like, what is this, you know? I mean, if you saw colors around,
or colors near. You have color near, maybe colors near.
What do we have?
Nearby colors.
Nearby colors. Yep.
That's interesting. I mean, that does tend to suggest that it isn't going to evaluate. That it's just a thing.
Mm-hmm.
I kind of like that. I mean, the only thing that maybe a little weird is that it suggests not red, but only things nearby.
Well, I mean, that can be gotten over. Is it a punctured neighborhood or an actual neighborhood? Do you know what I'm saying? That comes up everywhere, you know? Like limit wants a punctured one. And that's very important.
Yeah. Colors near. Well, okay. Colors near, nearby colors. Okay. So the first thing here would be the default case would be nearby colors. By the way, we've got a bunch of noise on the audio. Could we try to fix that? So the first thing would say nearby colors of color. We'd say, represents colors perceptually indistinguishable from blah, 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 from that color. Something like that. There's
Yep.
Phillips is suggesting isochromatic. It's cute, but I think
it's a correct term, but
right. And he's referring to the book Color for the Sciences. I have a copy of that book someplace.
I do too. Yeah.
Riemann metrics on color. Yeah, I remember some of that stuff. It's very cool. That's actually an interesting example of people, if you're trying to understand the Riemann tensor and all that kind of stuff, or you're trying to understand, no doubt there are interesting examples here. I mean, this is no doubt there are. Anyway, look, I think nearby colors is quite nice. And I think then here, okay, so let's take a look at what that would look like. Nearby colors of red, 0.1. Now you've got to be able to give, oh, what a mess. You've got to be able to give the space that it's in, right?
Mm-hmm.
And then you've got to say whether it's hard or soft or smooth or whatever.
Right.
And I really think that this is CIE. So
right.
There's no point in giving the CIE whatever it is until you've given a distance.
Right.
So, I mean, one possibility, maybe it's too grotesque, is to say something like, something like this. I mean, the distance here is always going to be a string name. Is that true? Or?
No, you can specify your own function.
Okay. Well, so that could be a function there. Or you can have an actual distance function, which gives that.
Right. And why do you want the cutoff method, hard, smooth, to be a part of that distance specification?
Well, because I think it's sort of related. I mean, are you suggesting it's a fourth argument or something?
Yep.
But you see, if we did it this way, then the case with the default, which is the default is CIE 76, is that true?
Mm-hmm.
So then we could get away with just doing this to represent smoothing around that. Is there a default where there's a second argument missing and where it's just smooth or not?
Sorry, what do you mean?
Okay, so
do we have it?
For example,
default?
if I would say color detect of, I wonder whether it should be nearby colors or colors nearby. I might prefer colors nearby. So let's do a color detect in the image, colors nearby red. Or we could say color replace image. Now, if I'm not mistaken, one thing we could say is colors nearby red, arrow, green or something.
Mm-hmm.
But that by default will take any color near red and map it into pure green, right?
Right. And now the new image recolor is adding methods for doing brightness preserving and so forth replacement.
So, okay, so what would that look like? Would that say by red?
So this would make image color replace more useful, but it would still not be useful enough, if you know what I'm saying. I mean, it might, the other use cases for that, what you're giving there on screen now.
By the way, the live stream, Ethan Black 86 suggests colors near, and I think you're right that colors near. Yeah, why not? Why not? Nearby is silly. There's no reason to say nearby. Because what it is colors near. Yeah, I like that. Anybody object to that?
Not me. I
Sounds
like
good
it
to me. Yeah, sounds good.
Okay, so let's go through this again. So in the case of color replace, when you're doing make my red, my red hues turn into, not hues, but, reddish things turn into greenish things. What is the specification for that? Is it red goes to green, or is it colors near red goes to somehow colors near green?
Color replace can only do reddish goes to green, to pure green.
I understand that, but you're saying you want to add methods to make it go reddish goes to greenish. Is that right?
We tried that, and the conclusion was that we introduced a new function, image recolor.
Okay, fine. Okay, so fine.
And that can do reddish to greenish, yes.
And how does it say? How does it specify that?
So currently, so for the input colors, you specify it with now colors near red, and then it gets whatever components of the color from the target color. So if you say I want it to be, say, brightness preserving, it preserves the brightness, but replaces the chroma components of the color.
Okay, I understand that, but I'm saying in the specification imagery color, does it look like this? Does it say colors near red, arrow green?
Yes.
And then it has some separate option that says, actually, I don't mean pure green. I mean, greenish with certain things preserved. Is that right?
Exactly. Yes.
Seems okay. All right, let's come back to the specification of colors near. Okay, so colors near red, comma, and now this putting in the smoothing thing in here is kind of weird, because ultimately what you're trying to do there is to say color detect of this, and you're trying to determine whether color detect is going to give you a hard edge at the edge of the nearness ball or not, right?
Right. I agree that probably is going to make more sense for color detect, not colors near.
I think so, because I think colors near is like it's a bin, and you can still say. So what you need is some kind of skin depth or something to colors near, and you want to say over what skin depth do you want to do that gradation? Is that correct?
Yeah.
It's okay. So so how would you want to specify that? That's part of I mean, you're not specifying. You're specifying distance minus d. What the heck? Well, there's 100 there. Where the heck did the 100 come from? I mean, this is some really bizarre arbitrary weight function.
Yep. It's arbitrary, yes.
So to me, a better way to do that would be in color detect. How would you do this? I mean, color detect, there's one thing that is just the ball of colors, near red. And the other is something where you are trying to go. I mean, I would have thought you want to have some decay function. Also blend other pixels. What do you mean within the region of interest? As in, okay, so look, the question is, does this have what does it look like? Is it that everything in the colors near red is precisely replaced by, is precisely becomes the white or whatever, value 1. And then there is a tail outside of that, which has a certain skin depth. Or do you want to start having values other than 1, even inside the ball that corresponds to colors near red?
Currently, that proportional thresholding method is actually doing the second thing you just explained. Even within the ball, we're proportionally recoloring.
Okay, so in fact, it has nothing to do with the nearness distance is merely, being provided sort of for, you're sort of hacking in that the ball size is going to be used to determine the exponent, right? Because it really isn't. I mean, go ahead.
I think you see there's a hard boundary, right, in the color space. Okay, so that's the first case, hard.
Yes.
Okay, now the question is, if you want to make that soft in various ways, so there are two proposed, I don't particularly like the way it's written up necessarily, but there are two proposed ways of doing it softer. One is proportional, which goes inside, outside, and the other one goes effectively outside only, right?
Right. So then I was right in my claim number 1. I think that in case what you're calling smooth here, it is in your color detection, any color that's within the ball gives 1.
Yep.
And colors outside the ball gradually decay off to 0.
Correct.
And that one decays awfully fast.
Yes.
Right. So we've got these different cases. So, I mean, what is the analog of the grayscale version of detection for other things other than, like edge detect doesn't have a grayscaling option, does it? It could have. What are the other detect functions? In principle, they could have grayscaling. That is, you've got your hard edge, and then you could put sort of grayscale around that hard edge, maybe. Did that make sense?
I would say a lot of binarization functions could take that.
Yeah, for sure. Right. And color quantization, maybe? No, maybe not. No. Maybe not.
No.
Wait a minute. How can binarization... Wait a minute. Binarization is trying to binarize things, but you're saying, well, actually, it's not binarizing, it's grayscaling.
Well, no, they are currently all binarizing, but I'm saying when it comes to using that binary segmentation as a mask, often it doesn't look good if you just stick in a binarized mask as the alpha channel or something. It's very common to want to blend or smooth a little bit.
Okay, so how do we do that in general? Do we have a mechanism for that? Because it sounds like we need then something which is a soft mask, so to speak.
Mm-hmm. Currently, we just blur. If you want it smoothed out, we just blur that binary mask.
Okay, but so then the basic bottom line is we don't have a general mechanism for this, and we're trying to put one in for the color case.
Correct.
I think we need a more general mechanism.
We have some things in threshold, which takes the soft thresholds as well. That's probably the only thing I can remember now.
What is the function called?
Threshold?
No, that's an option, right?
No, that's a function.
Oh my gosh. Do we refer properly between this and... Shouldn't this be in, like, all our sigmoid functions and things should refer to this, shouldn't they? Right?
It probably should, but they were introduced afterwards, right? So they should.
Yes. Okay, so that's another item, please. Somebody note that down, or do I get to do that?
No, I'm writing it down. I have no idea
Okay.
who gets that though.
You can send it to ILD. Send it to Sushma and ILD.
All right.
I think those functions are mostly came from the machine learning team. Like the ramp function, for example,
Right.
should certainly refer to threshold. And I don't even know what some of all these weird things in threshold actually are. Oh boy.
Well, there are pictures of them, and they're common thresholding.
Where are the pictures?
If you go down, I mean, we didn't do it back then.
I don't see any pictures.
I don't either, actually, right now. There should be.
There should be pictures. That would be very useful. Okay, so any of this thresholding could in principle be done for the color stuff too, couldn't it? Except your your thing called smooth is yet different from any of these. Am I making sense?
It is, yes.
You know, we were too hopeful in this meeting that this would be the last, because I'm running into another thing I have to go to. Let's just see here. Oh boy. Let me just ask here. Let me be able to go on for a little while longer here. Let me just see if I can push back the next meeting. Okay. Good. All right. So I'm not convinced here. So, I mean, it looks like that couldn't you implement any of all of these kinds of things? I mean, you really need some kind of, it seems like you need some kind of arbitrary, I don't really understand how this is going to work. So you get this soft mask here, and then what you can do with it. See what I'm saying? I mean, our other functions don't take soft masks like that.
Image functions, we have masking supported in many functions.
No, I know, but it's a hard masking, zeros and ones, isn't it?
No, we do accept grayscale masks as well.
Okay. Okay, look. So the question then is here, how does this relate to the many different thresholds that you might use? You know, why are you picking this particular one with this weird 100 in it?
I admit that's arbitrary. We can change that. It just gives a quick transition from the region.
I realize it gives a quick transition. I mean, I can see the 100 there.
Right.
The
question is that how far do you want to go from the region?
Well, yes. Right. And this seems to have things with parameterized, you know, I mean, in general, this function threshold seems to be a thing that would yeah. And that's really weird. Okay.
I agree we should at least come up with parameterized smooth method. Hard wouldn't have any parameters. Proportional doesn't need either. But smooth, I agree, we can have parameters.
Yeah,
we could have more settings, right?
But these are all functions. These are all pieces of color replace. I'm sorry. Yes. Yeah, of color detect.
No. Image recolor.
And color detect. Color detect now is going to be the one that returns the mask, a grayscale mask.
All right, look, let's try to hit if we can. I think there's a little bit more thinking to be done here, and I think we're going to have to come back one more time for this.
Okay.
Okay. But I think it's colors near is a good solution. Thank you to the folks on the live stream involved in suggesting that. Let's try and hit for 1 second image pyramid apply. Okay.
Okay.
See if we can.
And also we have, yeah, maybe we should do that. But I was thinking of the audio stuff. We have Carlo here.
Yeah, we're not ready to deal with annotations yet. We are not ready.
No, not annotations. I would suggest we do that on the other meeting later. But
yes, okay. But you're talking about audio identify?
No.
Short time Fourier stuff.
Well, I thought we'd come to a conclusion there, or did we? Are you now
No.
disagreeing with that conclusion?
Yeah. So the problem is that they're different things.
Okay.
Yeah. So a spectrogram has half the data that a short-term Fourier transform has.
I'm aware. Yep.
Okay. So when you want to, I still think your idea of having the gram function, in particular right now, spectrogram, return an object that happens to display as a graphic, but then can be computed with, and we can try to reconstruct the original signal. We can still, we can still call it inverse spectrogram, but it's not a true inverse. If you hear what I'm saying.
No, I understand. Okay, let me go through this, but once and for all, try to understand this. If you have a real function, a real signal, and you take its Fourier transform, you end up with this doubled thing, right? Oh, am I right? I mean, is it a pure? So, in other words, if I were to take, what's a good way to make some random signal? I don't know, some random walk. How do I get Roger? How do I get a nice random walk process? Do I do that? No. What do I do?
I don't. You have to look at the. I can't remember. I don't use this every day. Let's look at it. It has documentation.
I'm aware. Okay. All right. Well, this is going to be a mess to do this way. Can I do a Fourier transform of that?
Right.
Should be it. That should work. Can we make a note of that? Unless you disagree with it. Yeah. Okay. So here we've got this thing.
That
so now
might be wrong because it involves also the timestamps, which Fourier is not happy with. I think Fourier just wants the values.
Okay, whatever. Okay. Do I need to make a random walk myself?
No, you get the values out of that.
Yeah.
And instead of using normal, you get the values. You don't.
Someone on the live stream is very kindly sending us a function here for a. Okay. Well,
you still need the values.
Oh, values of this. Okay. All right. Okay. So if I say Fourier values of that.
No.
Oh, for goodness sake. What am I supposed to get?
Is this a property? It's a property of temporal data.
I don't know why values doesn't work on it, but anyway, that should probably work too. Okay. All right. Let's just do this. I would have been able to compute it myself in less time. Okay.
No.
Anyway.
No, you wouldn't.
Yes, I would. I would have just
for a Wiener process?
No, not for a Wiener process. Okay. All right. So anyway, so I've got Fourier here, and now I can say blah blah blah. Let's say I say list line plot abs of that. Okay, fine. All right. My question for the math folk here is, what is the relationship? I mean, is this, if I take a real signal originally, are these two, this is a naive math question, but are these two sides identical or not?
Complex conjugate.
Okay.
So the absolute value is the same.
Okay, fine. So are you telling me there's no new, if I have a real signal, is it true that there's no new information in the second part of the Fourier transform?
Yes, correct.
Okay, if I had a complex signal, there might be new information. Is that correct?
I'm not entirely sure, but it sounds reasonable.
Anybody else know? Roger, do you know?
Yeah, there would be. Yeah.
Okay, fine. Okay, so spectrogram is of real data. Therefore, the fact that you're only displaying half of the Fourier transform in the spectrogram is not losing information.
Yes,
the absolute value is.
Yeah, you only have the absolute value. So what it says that is the half of the things you plot here is reflected around the point where your mouse is. So the absolute value, the second half of the absolute value can be reconstructed from the first half.
Yeah, I get it. You've lost the phase information.
Yes.
Right.
Exactly.
Okay, I get the point. Yeah, I understand the point. And a spectrogram, could one imagine, I'm just asking the question, could one imagine a spectrogram where there's some hue for the colors that represents the phase information? I mean, right now we have a color intensity that represents the energy at that, in that frequency time.
But also that spectrogram is many Fourier transforms, one for each segment. If you see what I'm saying?
No, I understand that. But what I'm asking is, were you to color with a hue the spectrogram in addition to giving the intensity?
I think that's not called a spectrogram anymore.
Well,
you can definitely plot it, but it's not a spectrogram anymore.
No, but I'm just trying to ask, just for my understanding, if we had that hue information, would that be enough information to, store? Would that also store enough phase information that we could uniquely reconstruct?
Yes, but you need that. Here you are not storing the absolute value. So yeah, unfortunately, you can display only one at a time.
No, wait a second. But a spectrogram as we draw them right now is not in color, so to speak. It's only got
so this is just the periodogram. This is not a spectrum. As what Roger was saying before, this is just one frame of a spectrogram. What you do with the spectrum is you do these operations on partitions of data.
No, I get that. I get that. I understand. Okay. I'm saying that I'm asking you the question. Okay, so if I make, if I do, if I say this, hello there, and then I make a spectrogram from that.
One clearly could. So right now it's showing the amplitude there as sort of an intensity. Okay.
Yeah. Right. So
clearly one could code that up as a color, for instance.
And as I said, you can only display one time, either the intensity of or the phase. If your way of displaying it is an image and the color represents the value.
Why? This is color intensity here. This could be, look, the fact that this is in yellow is just decorative. This could be grayscale. And I could have, the phase is one number.
I see color and brightness.
Yes.
Okay,
right.
sorry.
So phases, right, I'm correct in saying the phase is a single number, right?
Yes, it is.
At each point.
Yes.
So in principle, I could have an enhanced spectrogram in which I see the phase.
Yes, indeed. Yes, if you have color, hue, and brightness, as long as you can display two things per each point, that's fine.
Right. Actually, someone on the live stream is pointing out that hue would be good because it has it's periodic, just like the phase is.
Yep.
Right.
Okay. So were we to have an enhanced spectrogram, we could have an inverse spectrogram that would actually work.
Yes. So the thing that I always try to point out is that is not the definition of a spectrum is that you take the absolute value and then
I get it.
The square of it.
Yeah, I get it. But I'm just trying to understand.
Yes.
In principle,
that would have an inverse.
Our spectrogram. Okay, so here's a way we could make this work. I'm not saying it's a good idea, but we could make this work. That when we ask for spectrogram, the thing behind the scenes is an object that contains phase information. Maybe this is a stupid idea because it's too much data and we don't need it and so on. But then we could faithfully get an inverse spectrogram from that behind the scenes thing, even though the display would only display the absolute value.
We went down there and the thing is, I realize you want that, okay? And
but it seems like there are plenty of operations that could be done, which are so.
But it muddles things. That's the thing. Okay, I think short-term Fourier transform is the thing that is the full data. That's the full data case. It's a well-known thing.
I know. There's nothing wrong with having short-term Fourier transform. Short-time Fourier transform. I don't object to that.
Good.
But I do object to having that return some kind of weird data container.
Well, it's going to have to do that. Yes.
Why?
Because it needs all the parameters. Yeah.
So what? Why isn't it just
Carlo?
You could say that about Fourier as well.
No.
Fourier just returns a list.
No, it has like one parameter.
Okay.
Yeah, there are many more parameters for.
Well, how many? What are they for?
Window size, window offset, window function.
Okay. This is no. Just a second. So your point is using Fourier is comparatively easy because all you need to know is one number. Using the output of short-time Fourier is difficult because you need to know a bunch of numbers in order to be able to do that reconstruction.
Exactly.
Okay, although mathematically, I could use, I mean, we went through this before. There's some association that gives, I mean, short time Fourier needs to have a second argument that is an association of these things like window, whatever it is, window size and so on, correct?
It just has essentially the same arguments as spectrogram, not a single argument with an association.
Okay, but what you're saying is you want, as a convenience to the user, to have, which I don't think is a convenience, I think it's a mess, to have the output be in some packaged object that also contains the information on how it was made.
Yes.
I mean, you could say that for a million other things, that you could want that. I mean, for Fourier, you could want that as well, but it's much more convenient in that case just to produce a list that you can then operate on with generic list operations rather than producing some weird object that has to have its own set of operations and where, you know, we fail to implement a bunch of those.
Yes.
I'm not convinced. I mean, if you want to do something, if you've got a short-time Fourier transform and it used particular window sizes, blah, 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 then you can, and you say, well, I want to do something. I want to invert that now. I've got to use the same window size. Well, you know, you should still have that association lying around that gave the window size. Just use it to do the inversion. See what I'm saying? I mean, you know, part of what you're assuming is that you'd never want to do an inversion with a different window size, that it always wants to be a thing where this is merely another representation. I'm not getting it. Yeah.
The data object that is backing this up, you can modify the data inside it, and that includes some of the parameters. Window size, of course, you cannot really change because it is...
Okay, but so you're making my argument for me. I mean, you're basically saying, don't store... Yeah, go ahead.
Yeah, so no, the advantage is that you can do your processing on the data, but then the container still keeps track of all the other parameters.
I know that, but you still have that information. I don't like the idea of having another container. I don't like these very special purpose containers. I think they cause us a lot of trouble. I think we're better off that you have to keep track of the, you know, the how it was made information and feed it back in when you need it, rather than have it carried around in a container. But I want to come back to the thing that I think is much more useful here, which is this notion of a spectrogram that you can operate on.
Yeah, I think that that's a pretty useful idea. And I think we could then apply actually the same idea to the other gram functions.
Like what?
Well, septogram, periodogram.
Okay, I'm less familiar with those, but yeah. I mean, yeah. But okay, so let's come to this question about phase information. Okay. So you say that there is there, in particularly in modern times, is there in fact a reasonable sort of pseudo-inverse like thing that you can do?
Yes.
Okay.
Even without there are phase reconstruction algorithms, and a couple of them are implemented in what currently is inverse short-time Fourier.
Okay.
And it would be better that those go away from there and
Yes.
go into inverse spectrogram.
Because the two operations are different. One is an approximate reconstruction, and the other one is essentially a perfect reconstruction.
Fine. All right. So then what I mean, let me make a crazy suggestion, right? That we actually have a function we could have a thing called phase spectrogram. Maybe there's a better name for it, which would be this color. I mean, I don't know if it's useful. Is it useful? Is a phased spectrogram useful?
I have seen it several times, so someone evidently uses it. I don't know the users of it. I have definitely...
Well, why don't you find out whether there's some... I mean, I just have no sense of whether that's something that comes up a lot. I just not, you know, phase is not something... yeah, I guess I don't really... we don't explicitly tend to sense phase, I guess, only implicitly so.
It's good for, like, phase is good for detecting things that change. abruptly. So that is one thing. I'm sure there are other uses now.
Okay, well, let's look at that. But in any case, so there's the possibility of some kind of phased spectrogram, maybe. I'm not sure. That would be the colorized version. Or alternatively, it could be some kind of option to spectrogram. And then there's the question of, do we, behind the scenes, when you make a spectrogram, do we make any attempt, to store the phase information or not? And is that a method option? See what I'm saying? We could have a method option such that spectrogram will store the phase, but not display it, or not store it and not display it, so that inverse spectrogram in that case would need to do phase reconstruction. Makes sense?
So the question here, I guess I could look at what you just said. If you computed a spectrogram, then you have the original data laying around. Why would you compute the inverse? So the point is, can you do some kind of processing on this, the data
right.
in the spectrogram?
Right. So
that is what the short time Fourier data allows. You can do processing and then invert it. But if it's a spectrum object that just displays as a graphics, I'm not sure how you...
No, that's the whole point. The whole point is to have spectrogram be a thing which displays as graphics, but which stores the data inside it. And the question is, does it store the phase data, or does it only store the intensity data? Right? So what would be some operations you might do? I think you should be able to do a bunch of audio operations on the spectrogram. I think it's very convenient to be able to say, slice up the audio, do this, that, and the other, tag the audio, et cetera, et cetera, et cetera.
The question is still, why would you do these operations on the spectrogram rather than the original signal, especially since most of these operations are natively applied to... So you would have to transform it back to a time domain, process it, and then go back to the short-time Fourier domain.
Well, there certainly are some operations like pitch shifting, which could easily be done on the spectrogram directly.
Yes. Yes, it's the complex spectrogram, let's say, not the...
Right. Yeah. Okay. But look, as a convenience to users, it's clearly the case that if you are displaying the spectrogram and you want to think about your audio in terms of spectrograms, you could go back to the audio and then say / spectrogram at the end of every line, right?
Yes.
But it would be nice to be able to just do these operations directly on a spectrogram object. It's like doing them in the frequency domain or something.
Yeah, the problem is that for most operations, it would be a lot of wasted computation.
Okay.
Because you would have to do this domain switch multiple times.
Okay.
That's the only disadvantage.
Okay.
I don't think it adds any value compared to just doing the operation on the audio object.
Let me remind you one of the reasons we want inverse spectrogram, and I hadn't really internalized this phase reconstruction business. Okay. If you are trying to sonify something, right? Let's say you've got some picture of a turtle. I don't know what. Black and white picture of a turtle. Okay. And again, it may be totally crazy, and I haven't, really had experience with doing it. But imagine that you view those pixels as like a score. A spectrogram, i.e., a spectrogram is sort of a representation of a score in some sense, if I'm not mistaken.
Yeah. Well, kind of, yeah.
Except for the fact that it's,
which are much bigger, smaller granularity, but yes.
Sure. And the other difference is, by default, at least it has a linear scale. It does not have can you make a spectrogram? Does it make sense to make a spectrogram with a log?
That is actually one of the most used features for neural networks, MEL spectrogram. So where the y-axis is aligned with the MEL scale, which is something that mimics human perception. Not exactly pitch, but still not linear.
Okay. So can we do that in our spectrogram?
There should be an option. I'm not sure if it was merged already. I'm not sure.
Okay, fine. But roughly, if I am to, in the inverse spectrogram case, and again, it may be crazy, but it seems like people want to do this kind of sonification method of, I've got this score-like thing, now generate audio from it.
Yeah, so actually this is, apart from I've got this score-like thing, let's generate audio, that's kind of like it's not something that is overly, it's interesting, but not overly useful. Now, the thing where this is used a lot and is super useful is, for example, you have a neural network that outputs, that is trained on spectrograms and outputs spectrograms, just real values, and the phase needs to be reconstructed. And this is because the neural network is huge and you cannot really train it on something with multiple channels. In that case, a lot of neural networks have as post-processing function something that does this inverse operation. So in that case, it's actually crucial for real-world applications. So,
okay,
and that exists already in inverse short-time Fourier. And as Roger was saying, it probably should live outside it and have exist in its own right, something that takes real data and then outputs a signal.
Okay, so fine. So what you're trying to convince me of, which you may very well be right about, is given a spectrogram or one of these sort of faux spectrograms without phase information, generate from it not a spectrogram. Oh, yeah, okay, fine. You're just saying we need a function that, given something which is equivalent to a spectrogram, generate a signal from it, right?
Yeah,
which is
right.
what we have been calling inverse spectrogram.
Yes.
And one of the issues...
Yes,
okay, I thought last time we had concluded that what we want is a function that will take essentially lists of data, will take a data array and treat that as a thing that is like some kind of spectrogram, and have the parameters to just take that data array and produce meaningful sonification of it.
Yeah. So what I'm trying to convince you of is that yes, we should have this spectrogram audio function or inverse spectrogram or however you want to call it, but short-time Fourier and inverse short-time Fourier and short-time Fourier data have added value independent of this, and they are fairly separate problems.
Look, I'm convinced that short-time Fourier makes sense. What I'm not convinced about is the container as the
okay. Okay, I see.
Okay. I think, unless proven otherwise, that it is a bad idea to introduce a new container, and that it's really, if you want your thing to be sensible, you have to carry around somehow the thing that you use to make it. I think otherwise, again, I've said this multiple times here. Otherwise, we have to make 100 functions support, various kinds of munging of short-time Fourier transforms.
So I understand that point. Now, the way we thought we would kind of get around the fact of creating 100 functions to deal with short-time Fourier data is having essentially properties that you can, if your short-time Fourier data object is S, you can say S data equals low-pass filter of S data, or whatever arbitrary function.
As an L value? Okay. Not a chance. No.
Okay.
I mean, that's even more crazy. The number of things we have to support if it's going to be an L value is even larger. The problem is there isn't a free, you might say, why isn't there a framework for just introducing things that have L values and this and that and the other? Well, the problem is, as is so often the case, there is actually no free lunch. You can't, these things actually have to be done in detail for each case because they're actually different. It's not something where you can generically say, just introduce an L value. Yeah,
I mean, there is a framework, the one that Tali came up with.
I'm aware of that. Yeah. I'm aware, but it's not the right. That's only the beginning of the story for something which is a computational function like this. It's one thing to have something like persistent value, which is just a storage mechanism. Anyway, look, it sounds like, unfortunately, we really have now run out of time. It sounds like we have some path forward, although there's more to be thought about this inverse spectrogram thing. But I don't think that necessarily inverse spectrogram is the right name, because really what it is is, it's more like,
It's like reconstruct, refined. Yeah. But I was thinking that you would be able to come up with a...
Well, I think it's spectrogram audio, which is what we talked about last time.
Oh.
Which takes data, like it takes a random data array. It's got to be given certain parameters that say, okay, this is the data array. Like, what do the rows of the data array mean? Right? Like, so let's say I got my bitmap from a score, effectively, right? The rows of my data array, in that case, mean...
No, I understand. You're just giving a different name to inverse spectrogram.
I think so, because
are we missing a case now? Or isn't there like a data case for spectrogram? And now I can't get the data case out. There's only getting audio out.
For which? For
spectrogram, doesn't it take just raw data as well?
It does.
Yes.
Okay. Right. So now I can't do the reconstruction to raw data. I can do reconstruction to audio, but I can't do we care?
Yeah, I'm not sure. I think we do care, actually. We have run out of time. I really want to, the other thing we got to do is that image pyramid apply, and I'm really distinctly, that's another one of these things that has some crazy, where you've got a crazy wrapper object. Oh boy, I need to understand this better. I mean, your basic point with image pyramid is this is a representation of... I don't get this at all. I'm sorry, I just don't get this. I don't understand why image pyramid isn't basically just an alternate representation of an image, just like image data. You've got various ways, like interleaving goes to true and false and things like that. And right, so there's different ways of representing our live stream participants. I appreciate their enthusiasm of suggesting that I cancel the rest of my afternoon, but I can't do that. I'm going off on a trip on Monday, and I've got a whole bunch of things to finish. So unfortunately, I really have to go to these other ones, which are also important. Roger, can you? I'm sorry. This is this microcontroller kit review. Yeah. What roughly is that?
Okay, so this is the elevator speech. This is the ability to generate embedded code that runs on microcontrollers and microboards.
As opposed to distinct from the Arduino link mechanism.
Right, which is just sort of remote control of slow things. This actually downloads and runs code. So if you need to run a controller I get it. Right. Okay. Signal processing, those kinds of things that need to actually run live, fast, even if it's an 8-bit controller.
Okay. All right. I get it. Okay. Sadly, I have to go here. I'm sorry. And I appreciate, but I just want to make my case just for 1 second. I'm really, really late here. That image pyramid is in a sense merely a re-representation of an image.
So are transforms, right? What's Fourier transform? It's merely a re-representation of the function, right? Yeah. LU decomposition. It's merely a re-representation of the matrix. So happens to be useful, right?
Fair enough. Yeah. But so LU decomposition, we actually currently return as a list of matrices, right?
Yeah. Well, that one is odd for various reasons. But that's a long history going back to 1.0 or something.
Okay. But in any case, the issue here is, okay, is the image pyramid, when you want to do things with an image pyramid, is it that you want the pieces of the pyramid out? Or is it, anyway, I'm sorry, we need...
It's a bit too long.
Right. Okay. To be continued. And Okay, so sadly we need
Stephen,
another of these meetings.
You know, I'm going to be out for a couple of weeks. If more of these are scheduled, I can try to join, but no promises.
Okay. Well, we might be able to do it on Monday before I have to get on a plane.
I'm getting on the plane in a couple hours.
Oh, you are? Okay.
Yeah.
Okay. Well,
yeah.
So much for that. Well, let's see whether we can schedule it at a time when you will be around then.
Okay.
And okay, great. Maybe we'll even live stream the thing about microcontrollers, unless Roger.
No, it's okay.
Okay, well, let's plan on doing that. So,
Right.
for people who are into this, if you want to hear about microcontrollers, that would be at let's see, it would be about about 2 hours from now. So, thanks to everybody on the live stream. Much appreciate your input, and talk to you all soon.